Welcome. Today we're diving into the fascinating world of probability. At its core, probability is a branch of mathematics that deals with the likelihood of events happening. Whether you're flipping a coin, rolling dice, or predicting the weather, probability helps us make sense of uncertainty. It gives us a way to quantify how likely something is to occur using numbers between 0 and 1. If something is impossible, its probability is 0. If it's certain, the probability is 1. Everything else falls somewhere in between. Let's start by exploring the basic concepts and see how probability shapes our understanding of everyday events. Probability isn't just for mathematicians, it's all around us in daily life. Think about checking the weather forecast before leaving home. When you hear there's a 70% chance of rain, that's probability in action. Or consider playing a board game and rolling a die. The chance of rolling a 6 is a classic example of probability. Even deciding whether to bring an umbrella or not is a decision influenced by probability. By understanding these everyday examples, we can see how probability helps us make informed choices and manage uncertainty in our lives. Talk about probability, we use specific terms. An event is something that can happen, like drawing a red card from a deck. The outcome is the result of a single trial, such as drawing a specific card. The sample space is the set of all possible outcomes. For example, when flipping a coin, the sample space is heads or tails. Understanding these terms helps us communicate clearly and solve probability problems more effectively. Let's look at each term in more detail as we move forward. Let's break down the difference between an event and an outcome. An outcome is a single possible result, like rolling a 4 on a die. An event, on the other hand, can include one or more outcomes. For example, the event rolling an even number includes the outcomes 2, 4, and 6. By grouping outcomes into events, we can calculate the probability of more complex scenarios. This distinction is key to understanding how probability works in practice. Sample space is a fundamental concept in probability. It's the complete list of all possible outcomes for a given experiment. For example, if you toss a coin, the sample space is heads and tails. If you roll a standard 6-sided die, the sample space is the numbers 1 through 6. Knowing the sample space allows us to calculate probabilities accurately because it shows us all the options available. Let's see how to list the sample space in different situations. Probability is measured on a scale from 0 to 1. Probability of 0 means an event is impossible, while probability of 1 means it's certain to happen. Most events fall somewhere in between. For example, the probability of flipping a coin and getting heads is 0.5. This scale helps us compare the likelihood of different events and make better decisions. Understanding where an event falls on the probability scale is a crucial skill in both math and real life. Calculate the probability of an event. We use a simple formula. Probability equals the number of favorable outcomes divided by the total number of possible outcomes. For example, if you want to know the probability of drawing an ace from a standard deck of cards, there are 4 aces and 52 cards in total. So the probability is 4 divided by 52, or about 0.077. This formula is the foundation for solving many probability problems. Let's look at a simple example. Suppose you roll a 6-sided die. What's the probability of rolling a 3? There's only 1 3 and 6 possible outcomes, so the probability is 1 divided by 6, or about 0.167. This straightforward approach can be used for any event where all outcomes are equally likely. Practicing with simple examples helps build a strong foundation for more complex problems. Key assumption in basic probability is that all outcomes are equally likely. This means each possible result has the same chance of occurring. For example, when flipping a fair coin, heads and tails are equally likely. If outcomes aren't equally likely, we need more advanced methods to calculate probability. Recognizing when outcomes are equally likely helps us apply the basic probability formula correctly. Let's talk about the extremes of probability: impossible and certain events. An impossible event has a probability of 0. For example, rolling a 7 on a standard 6-sided die is impossible. A certain event has a probability of 1, like drawing a card from a deck and getting a card, because every draw results in a card. Understanding these extremes helps us interpret probabilities in real-world situations. Every event has a complement, the event that it does not happen. For example, if the event is rolling a 4, the complement is not rolling a 4. The probabilities of an event and its complement always add up to 1. This concept is useful for solving problems where it's easier to calculate the probability of the complement and subtract from 1. Mutually exclusive events are events that cannot happen at the same time. For example, when rolling a die, getting a 3 and getting a 5 are mutually exclusive. You can't roll both at once. Understanding mutually exclusive events helps us add probabilities correctly when considering multiple possibilities. Dependent events are events where the outcome of one does not affect the outcome of the other. For example, flipping a coin and rolling a die are independent. The result of the coin flip doesn't change the die roll. Recognizing independent events is important for calculating combined probabilities, especially in more complex scenarios. Dependent events are the opposite of independent events. Here, the outcome of one event affects the probability of the other. For example, drawing 2 cards from a deck without replacing the first card changes the probability for the second draw. Understanding the difference between independent and dependent events is crucial for solving probability problems accurately. Addition rule helps us find the probability that at least one of 2 events happens. For mutually exclusive events, simply add their probabilities. For example, the probability of rolling a 2 or a 5 on a die is the probability of 2 plus the probability of 5. If events aren't mutually exclusive, we need to adjust for overlap. This rule is a powerful tool for combining probabilities. Multiplication rule is used to find the probability that 2 independent events both happen. Multiply the probability of the first event by the probability of the second. For example, the probability of flipping 2 heads in a row is 0.5 times 0.5, which equals 0.25. This rule is essential for calculating probabilities in multi-step experiments. Tree diagrams are a helpful way to visualize all possible outcomes of a probability experiment. Each branch represents a possible outcome, and following the branches shows all combinations. Tree diagrams are especially useful for multi-step problems like flipping coins multiple times or drawing cards in sequence. They make complex problems easier to understand and solve. Venn diagrams are another tool for understanding probability. They use overlapping circles to show relationships between different events. Venn diagrams help us see which outcomes are shared between events and which are unique. This is especially useful when dealing with events that are not mutually exclusive. By visualizing the overlap, we can calculate probabilities more accurately. Experimental probability is based on actual experiments or observations. It's calculated by dividing the number of times an event occurs by the total number of trials. For example, if you flip a coin 100 times and get heads 48 times, the experimental probability of heads is 48 divided by 100, or 0.48. This approach is useful when theoretical probabilities are hard to determine. Theoretical probability is what we've been discussing so far. It's based on reasoning and known information, not experiments. For example, the probability of rolling a 3 on a fair die is 1 divided by 6 because each outcome is equally likely. Theoretical probability is often used when all outcomes are known and equally likely, making calculations straightforward. The law of large numbers states that as you repeat an experiment more and more times, the experimental probability will get closer to the theoretical probability. For example, if you flip a coin thousands of times, the proportion of heads will approach 0.5. This law explains why experiments become more reliable with more trials. Probability plays a huge role in games, from board games to sports. Understanding the odds can help you make better decisions, whether you're deciding which move to make or how to manage risk. For example, knowing the probability of drawing a certain card can influence your strategy in a card game. Probability adds excitement and strategy to many games we play. Weather forecasts use probability to communicate uncertainty. When you hear there's a 60% chance of rain, it means that, in similar situations, rain occurred 60% of the time. Meteorologists use data and models to estimate these probabilities, helping us plan our activities and stay prepared for changing weather. Doctors and researchers use probability to assess risks and make decisions. For example, the probability of a treatment being effective or the risk of side effects. By understanding these probabilities, medical professionals can recommend the best options for patients and improve health outcomes. Probability is essential in finance for assessing risks and making investment decisions. Financial analysts use probability to estimate the chances of different outcomes, like stock prices rising or falling. By understanding these probabilities, investors can make informed choices and manage their portfolios more effectively. Insurance companies use probability to set premiums and assess risk. By analyzing data on accidents, illnesses, and other events, they estimate the likelihood of claims. This helps them determine how much to charge and how to manage their business. Probability is at the heart of the insurance industry. Technology and computer science use probability in many ways, from algorithms that filter spam emails to artificial intelligence that predicts user behavior. Probability helps computers make decisions under uncertainty and improve their performance over time. It's a key part of modern technology. Scientists use probability to interpret experimental results and make predictions. For example, in genetics, probability helps predict the likelihood of inheriting certain traits. In physics, it's used to describe random processes. Probability is a fundamental tool for scientific discovery and understanding. Sports analysts use probability to predict outcomes, set odds, and develop strategies. For example, the probability of a basketball player making a free throw can influence coaching decisions. Understanding probability helps teams and fans appreciate the uncertainty and excitement of sports. Probability is everywhere in our daily lives, from deciding when to leave for work to choosing what to eat. We constantly make decisions based on the likelihood of different outcomes, even if we don't realize it. By understanding probability, we can make smarter choices and better manage uncertainty. Probability helps us assess and manage risk. Whether it's crossing the street, investing money, or trying a new activity, understanding the chances of different outcomes helps us weigh the risks and benefits. By applying probability, we can make more informed and safer decisions. Uncertainty is a part of life, and probability is our tool for dealing with it. By quantifying uncertainty, we can plan for different scenarios and make better decisions. Probability doesn't eliminate uncertainty, but it gives us a way to understand and manage it. Probability and statistics are closely related fields. Probability deals with predicting the likelihood of future events, while statistics involves analyzing data from past events. Together, they help us make sense of the world and make informed decisions based on data and chance. Randomness is at the heart of probability. A random event is one where the outcome cannot be predicted with certainty. For example, shuffling a deck of cards or spinning a roulette wheel. Probability gives us a way to describe and analyze random events, even when we can't predict the exact outcome. Probability distribution shows how probabilities are assigned to different outcomes. For example, the distribution for rolling a die assigns a probability of 1/6 to each number. Probability distributions are used in many fields to model and analyze random processes. Probability can be divided into discrete and continuous types. Discrete probability deals with countable outcomes like rolling dice. Continuous probability deals with outcomes over a range like measuring the time it takes for a bus to arrive. Understanding the difference helps us choose the right methods for different problems. Conditional probability is the probability of one event happening given that another event has already occurred. For example, the probability of drawing a red card from a deck, given that the first card drawn was black. Conditional probability is important for understanding how events influence each other. Bayes' theorem is a powerful tool for updating probabilities based on new information. It's widely used in fields like medicine, finance, and artificial intelligence. Bayes' theorem helps us revise our predictions as we gather more data, making our decisions more accurate over time. It's easy to make mistakes with probability, like confusing independent and dependent events or misinterpreting percentages. Being aware of common pitfalls helps us avoid errors and make better decisions. Practice and careful thinking are key to mastering probability. Probability is a valuable tool for decision making. By weighing the chances of different outcomes, we can choose the best course of action. Whether it's in business, health, or everyday life, probability helps us make choices that are more likely to lead to success. Probability allows us to make predictions about the future. While we can't know exactly what will happen, we can estimate the chances of different outcomes. This ability to predict is useful in fields from science to sports to business, helping us prepare for what's ahead. Probability is often used to ensure fairness, especially in games and competitions. By designing rules so that each participant has an equal chance of winning, we create fair and enjoyable experiences. Understanding probability helps us recognize and appreciate fairness in different situations. Probability isn't just a mathematical concept, it's a practical tool for navigating the real world. From planning trips to making investments, probability helps us deal with uncertainty and make better decisions. By mastering probability, we gain a powerful advantage in life. Let's recap what we've learned. Probability is the study of chance and uncertainty. We've explored key terms like events, outcomes, and sample space and learned how to calculate probabilities. We've seen how probability applies to games, science, finance, and everyday life. By understanding probability, we can make smarter decisions and better manage risk. Now that you have a solid understanding of the basics, you're ready to explore more advanced topics in probability. From probability distributions to statistical inference, there's a whole world to discover. Keep practicing, stay curious, and remember, probability is a powerful tool for understanding and navigating the world around us.